Assume that the only assets available to an investor are the stocks of two companies, NBI and Applicable Inc. NBI has an expected return of 6%, and Applicable's expected return is 12%. The standard deviation of the stock returns is 25% for NBI, 42% for Applicable. The correlation coefficient between the two stock returns is minus 0.35. There is no risk-free asset. The investor maximizes a utility function that is quadratic, so it equals to expected return minus sigma squared. In other words, the risk aversion coefficient is 2. The investor has to invest all her wealth in a portfolio consisting of these two stocks. Okay, first question. What fraction of her wealth will she invest in NBI? Now we're trying to solve the optimal portfolio that maximizes the utility level with two risky assets. So for these kind of questions, we need to use the solver in Excel spreadsheet to solve it. So let's go to Excel spreadsheet and let's enter all the numbers here. So first, expected return for NBI is 6%, applicable 12%. Standard deviation, 25%, 42%. Correlation, minus 0.35. Risk aversion is 2. Let's pretend that we know the portfolio weight. Let's say it's 0.5 for now. So 0.5 is in NBI and another 0.5, that's 1 minus 0.5 is in Applicable, and the functional form is here. Now, pay attention. You need to enter this as a function instead of a number here, because we're just pretending that the NBI is getting 0.5 weight and that optimal weight may not be 0.5, and we need to solve for it. So all the variables need to be updated at the same time. So we're entering it as a function here. Next, we want to maximize the utility level, which equals to expected return minus variance. So we need to calculate expected return and variance first. So let's start with expected return. Expected return equals to portfolio weighted sum of individual assets expected returns. So that's 0.5 times 6% plus C7.5 times applicable 12%. And that gives you 9%. I have put down the formula in red here so that you can review the formula. Next, we calculate the variance. Variance equals to W1 squared times sigma 1 squared plus W2 squared times sigma 2 squared plus 2 times W1 W2 times covariance. That's correlation times sigma 1 times sigma 2. And that gives you 4.14% variance. The utility function equals to expected return minus variance B11. So if we put 0.5 weight in MBI, 0.5 weight is applicable, we will get a utility level of 0.049. But remember that this is not the optimal portfolio weight. 0.5 is just a number that we pretended that it is actually the correct answer, and see what the utility function level. To find the optimal portfolio, we need to find the optimal W that maximizes utility. So we need to use this solver function, or the solver plugin in Excel. To make sure that it is enabled, you first go to Tools and find Excel Add-ins. And you want to make sure that this solver add-in is ticked, so it's chosen. If you download it from OSU, download Excel from OSU's website, OSU packages, it's always included automatically. You just need to make sure that it's checked. Okay, we have selected that. Then you go to Data, and here you should have your solver. You click on the solver. So what does the solver do? We want to find the W that maximizes utility, that's B12. So you put down B12 here, and you want to maximize it. So which variable do you allow it to choose? You choose B7. Then you click Solve. Okay, it has found a solution. You can click OK to accept the value. So you see that the value has changed from 0.5 to 0.586. And this is a solution for the first question. So this is a fraction of her wealth that she should invest in MBI. So we put down 0.586 here for question A. Second question. Let's continue with the same information and assumptions as in the previous question. The investor wants to maximize the risk of her portfolio, wants to minimize the risk of her portfolio. So what percentage of her assets should be invested to MBI? So this investor has changed. She's no longer maximizing the utility. She only wants to minimize the risk of her portfolio, which is measured by variance. So we can change our server. Now we want to choose a W that minimizes the variance, which is B11. So you put down B11 here, and you change the objective to minimize instead of maximize. The choice variable is again the portfolio weight, B7. Then you click Solve. And you see that the number in B7 has changed to 0.68. So if the investor is more risk averse and only wants to minimize the risk of her portfolio, she would pick 0.682 weight in MBI and the rest in applicable.com. Final question. Assume that the risk-free rate is available and has a return of 2.5%. So what is the weight of MBI in the portfolio of the two stocks with the maximum Sharpe ratio? Now we have three assets. We have risk-free asset and two stocks. We want to find the optimal combination of the two stocks, which is a tangency point of the risk-free rate, CAL, the steepest CAL line, capital allocation line, to the efficient frontier with these two risky assets. So this point should give you the highest or maximum Sharpe ratio. So let's pretend that we know W for now and calculate the Sharpe ratio. Let's put on risk-free rate here. The Sharpe ratio would be calculated as the excess return of the portfolio, which is B10, minus risk-free rate, that is B17. Divided by standard deviation of the portfolio. So that's square root of the variance. That's B11. Okay. If we put portfolio weight 0.68 in MBI, then the Sharpe ratio is 0.3. Now we want to optimize, we want to choose W to maximize the Sharpe ratio. We'll go to solver again. What we want to solve, maximize is B18, the Sharpe ratio. We want to maximize it, so you choose the max. And the choice variable is again W. It's B7. So you click solve again. And the solver gives you a solution of 0.572. So the optimal weight of MBI that maximizes the max Sharpe ratio is 0.572.